All right, last video lesson of the year. So here's our unit 7 and 8 diagnostic. Off we go. So we have secant of 5 pi over 4 minus 1 over cosecant of 3 pi. I'm just going to convert these to degrees. I think people like that a little better. Pi is 180 degrees times 5 divided by 4 is 225. You can check me on the math. Minus 1 over cosecant. 3 pi would be 3 times 180, which is 540. All right, so secant of 225, that's the reciprocal of cosine of 225. 225 degrees is in the third quadrant with a reference angle of 45. You can get that by doing 225 minus 180. And my reference triangle would have a -1, -1, and a radical 2. So my secant is the reciprocal of cosine, so that would be hypotenuse over adjacent. And that is radical 2 over -1, otherwise known as negative radical 2. Now, 1 over cosecant of 540 is just as good as sine of 540, and that's a little bit more familiar. 540 is 180, 360, and 540, so I end up here. I can use the unit circle concept where sine is the coheight. Sine is the height, rather, excuse me. Sine is the height and cosine is the coheight, so sine of 540 is the height, which is 0 at that point, so we get negative radical 2. All right, next question. So I have tan of negative 5 pi over 6 plus 4 ln of e of cos of pi over 6. Tan of 5 pi over 6 is as good as tan of negative 150, so we'll take care of that first. Negative 150 is in the third quadrant again with a reference angle of 30. And so my triangle can be labeled as such: -1 opposite, negative radical 3 adjacent, and 2 on the hypotenuse. So tangent of negative 150 is opposite over adjacent, so I get -1 over negative radical 3, which is 1 over radical 3, or radical 3 over 3. So back to the top here, so we have plus 4 ln of e to the cos pi over 6. So I have 4 ln of e to the something, which is just the something. So this is 4 times cos of pi over 6. So I have plus 4 cosine of 30 degrees. So 30 degrees is the first quadrant, in the first quadrant. So we have a 1 opposite, a radical 3 adjacent, and a 2 hypotenuse. Cosine is adjacent over hypotenuse, so I get radical 3 over 2. So I would get radical 3 over 3 plus radical 3 over 2. And if you want to put that together, that's fine. That would be an easy expectation on a test, so we can do that here also. You can multiply this guy by 2, multiply this guy by radical 3. You would get 2 plus 3 over 2 radical 3. You would get 5 over 2 radical 3, or 5 radical 3 over 2 times 3, which is 6 if you rationalize. So you could have any answer. I would accept. On a multiple choice, you could get any of those as the choice. All right, number 3, we have 1 over cosecant of 240 minus log base 2 of cotangent of 300 over secant of 150. I'm already in degrees, which is nice. This guy is sine of 240. 240 is in the third quadrant with a reference angle of 60. So opposite the 60 is negative radical 3. Adjacent is -1. My hypotenuse is 2. Sine is opposite over hypotenuse. I get negative radical 3 over 2. And you should be able to do it with the relative speed that I can, to be honest with you. And now we have log base 2 of cotangent of 300 over secant of 150. You could go many routes here. One route you could go is that secant of 150 is 1 over cosine, so this becomes cosine of 150 over cotangent of 300 is 1 over tangent of 300. So I can write that in here. And then I can get cosine of 150 and tangent of 300. Again, this is not necessary. If you can just find the cotangent of 300 without rewriting it, you can do that too. So anyway, let's see. Cosine of 150. 150 is in the second quadrant with a reference angle of 30. So opposite the 30 is a 1. Adjacent would be a negative radical 3, and hypotenuse is 2. So now I have log base 2 of cosine of 150, which is adjacent, negative radical 3 over hypotenuse 2. Then I have tan of 300. 300 is in the fourth quadrant with a reference angle of 60. Opposite is negative radical 3. Adjacent is 1. Hypotenuse is 2. Tangent is opposite over adjacent, so I get negative radical 3 over 1. So now I have to simplify this. I have minus log base 2 of negative radical 3 over 2 times negative 1 over radical 3. Keep change flip, if you will. My radical 3's go away. My negatives multiply to a positive, so I get minus log base 2 of a half. And log base 2 of a half, what power of 2 gives you 1/2? That power is negative 1. But I'm subtracting that negative 1, so I get negative radical 3 over 2 plus 1, which again, you could combine into one fraction if you so desired. Okay, next question, number 4. We have inverse tan this time of negative radical 3 over 3 minus inverse cos of negative 1/2. So this is a good time to review our ranges for inverse functions. The range for inverse sine is negative 90 to 90, or negative pi over 2 to pi over 2. And you can look back at the lessons as to why that's the case. Inverse cosine from 0 to pi. Inverse tangent is negative pi over 2 to pi over 2, not including, excuse me, sorry for that mistake, not including the endpoints. And you can look back to the graphs as to why that's the case. So inverse tan of negative radical 3 over 3, tangent is negative in the second and fourth quadrants, and inverse tan can only spit out angles in quadrants 1 and 4. So right now I'm in quadrant 4, and I'm looking for an angle whose tangent is radical 3 over 3. So if I think about what happens there, my tangent is negative radical 3 over 3, which if I were to like de-rationalize this, and you can do that by multiplying top and bottom by radical 3 over radical 3, I would get negative 3 over 3 radical 3, which is negative 1 over radical 3. And I hope you realize that if I put a reference angle of 30 here, negative 1 over radical 3 gives me the reference angle of 30 degrees in the fourth quadrant gives me the proper tangent. So this guy is negative 30 degrees. I asked you to report the answers in radians. So this guy up here is negative pi over 6. Okay, so now cosine inverse of negative 1/2. Same thing, which quadrant am I in? Well, cosine is negative in quadrants 2 and 3, but inverse cosine only spits out angles in quadrants 1 and 2, so I have to be in quadrant 2. Quadrant 2, to get a cosine of negative 1/2, I would have to be adjacent negative 1, hypotenuse 2. This guy would be radical 3, and I'm looking at a reference angle of 60. So I'm looking at this answer being 120, which is 2 pi over 3. So here's my answer, and now I can combine that into one fraction. Negative pi over 6 minus 4 pi over 6, which gives me negative 5 pi over 6. Final answer. Okay, next up, number 5. So I have cos inverse of this blah. So we have sine squared of 3 pi over 5 plus cosine squared of 3 pi over 5. You need to recognize this. Sine squared of an angle plus cosine squared of the same angle is always 1. That's called the Pythagorean identity. So this is cos inverse of a half. And cos inverse of a half, so we're in the first quadrant. Cosine is a half. So I have 1, 2, radical 3. And that angle would be 60 degrees, which is pi over 3. Okay. Number 6. We have secant of inverse tangent of negative 15 over 8. Woo! Okay. So I have secant of an angle. This inverse tangent thing is an angle. Inverse tangent eats the ratio and spits out the angle. So I have to figure out like what's going on with this angle. So inverse tan can spit out answers between negative pi over 2 and pi over 2. Well, since we are in there, that would give us the fourth quadrant of the first quadrant. Tangent is negative, so we're going to be in the fourth quadrant. So I'm going to draw a fourth quadrant angle, and I know the tangent is negative 15 over 8. I would like the secant of this angle. I'll call it theta. Well, secant is the reciprocal of cosine, which requires the hypotenuse. So I now need to use the Pythagorean theorem to go grab the hypotenuse. So negative 15 squared is 225. 8 squared is 64. 225 and 64 are 289. Take the square root. C is 17. So now I have the secant of the angle. Whoops, I keep writing that. I don't know why, because I can do it right now. Secant is the reciprocal of cosine, otherwise known as hypotenuse over adjacent. So this would be positive 17 over 8, not negative, because we're in the fourth quadrant, and cosine and secant are both positive in the fourth quadrant. Okay. Number 7 says circle all expressions below that are equal to cos of 140. For each expression you do not circle, provide a reason why you didn't. This was a test question this year. And I like this test question, actually, because it kind of, you can't just get these values. You kind of have to understand the unit circle and stuff like that. All right, so 1 over secant of 140, well, that is cosine of 140 by definition. Cosine and secant are reciprocals. Done. Negative cosine of 220. Well, cosine of 140 is a negative value because we are in the second quadrant. And by the way, 140 has a reference angle of 40 in the second quadrant. You can do that by 180 minus 40. Sorry, 180 minus 140 to give you 40. So cos of 220 itself, 220 is in the third quadrant, that quantity is negative, but then I'm multiplying it by negative and I have a positive. So cos of 220 is less than 0. So negative cos of 220 is greater than 0 and cannot be equal to cos of 140. I'm being a little pithy with that explanation, but I'm also explaining it as we go. All right, cosine of negative 220. Well, negative 220 is 90, 180, and another 40 to get us to 220. It is coterminal with 140. So these values are identical. Okay, so I'm not circling B, I'm circling C. Negative 220 is coterminal with 140. So any trig function would agree with it. Negative cosine of 40. Well, cosine of 40 is positive, and cosine of 140 is just the opposite of that because cosine 140 is in the second quadrant, so this works. Okay, same reference angle. It says the same reference angle and the same sign. All right, negative cosine of 320. Well, where is 320? 320 is in the fourth quadrant. 90, 180, 270, and another 50 gives us 320, which gives us a reference angle of 40. Now, we're in the fourth quadrant, so cosine is positive. We have the same reference angle, and since cosine is positive and we're multiplying by negative, this equals a negative. And we have the same reference angle, so we're good to go. E works. All right, F, sine of 50. So sine of 50, that's an interesting one. So sine of 50, if I have 50 degrees, notice I have 40 up here. Sine of 50 would be, I'm just going to call this B over C. So would the cosine of 40. So sine of 50 is actually equal to cosine of 40. But cos of 140 equals negative cos of 40, not positive cos of 40. So this actually is out. It's close. They have the same numerical value, but different signs. All right, F, we have negative 1 over cosecant of 230. That's the same thing as negative sine of 230. And 230 is in the third quadrant, so we have 1, 2, 3. With a reference angle of 50 again. Reference angle of 50. So this is actually, so sine of 230 is the same as the negative sine of, the negative sine of 50, which is the same as negative cosine of 40. But we have the negative cosine of 40, which is just cosine of 40. And so this is not correct for the same reason. So negative sine of 230 is positive, but cosine of 140 is negative. They actually, again, they have the same numerical value, which if you really want to see on the calculator, you could do this. So you could see, just to check, sine of 230, okay, boop, cosine of 140. Hopefully I'm in degrees. Yep. Okay, they actually have the same value, but I asked you for negative sine of 230. All right, H. H, we have cotangent of 140 times sine of 140. Okay, so cotangent of 140 is cosine of 140 over sine of 140. That's an identity you need to know. Times sine of 140 over 1. The sine of 140's cancel, and I just get cosine of 140. So that guy works. I love that question. I think that's a good conceptual question that's not particularly difficult, but really, hones in on whether or not you know this. All right, number 8, we want to fix this. We want to simplify this using identities. So sine squared x. So we have sine squared x plus cosine squared x equals 1. You have to know that. That is one of the chief things you need to know coming out of this course. Just you have to know that and why it works and all that good stuff. Okay, so sine squared x, if I manipulate this, if I subtract cos squared x from both sides, sine squared x is 1 minus cos squared x. Okay, so we have 1 minus cos squared x over 1 minus cos x minus cos x. 1 minus cos squared can be factored into 1 minus cos x times 1 plus cos x, just by using the difference of two squares factoring. And then this is very nice because it kills off the 1 minus cos x. So I have 1 plus cos x minus cos x, and this just comes out to be 1. How nifty is that? There are other ways to do this, by the way. You can combine this into one fraction by multiplying this guy by 1 minus cos x if you wanted to. And there are other ways to do this, but that's actually probably the quickest way. All right, 9, I have cos x plus 1 over 1 plus secant x. So cos x plus 1, not a lot I can do with that, but on the bottom I can rewrite secant x as 1 over cos x. And then I get a complex fraction that I can multiply top and bottom by cos x to get rid of the baby denominator. So I'll multiply that through. I get cos squared x plus cos x over cos x plus 1. And now, again, I can factor the numerator. I can factor out a cosine from the numerator. And I get cos x plus 1 over cos x plus 1. And those cos x 1s can go away. And I'm just left with cos x. I think these are fun because you get something nice and simple at the end. All right, number 10. So we have sine x times secant x plus cotangent of x minus cosine of x. All right, well, I have sine of x times, let's see what I can do with this. Secant is 1 over cosine. See, sometimes you're just going to start with something you know. Cotangent is cosine over sine. And then I'm subtracting cos x. So I'll distribute this. I get sine x over cos x plus, when I do sine x times cosine over sine, I get rid of the sine. And look at that. The cosines will cancel, and sine over cosine is tangent of x. See? Simple. All right. Number 11, I have sine of inverse cosine of x over tan of inverse cosine of x. Well, sine of inverse cosine, not a lot I can do with that. But I can do something with the tangent. I can say, when I have 1 over tangent, that's cotangent. And cotangent is cosine over sine. So it's cosine of cos inverse. I'm not changing what's inside the trig functions. So just to recap that, I probably went a little fast there. This thing is the same as bringing up cotangent of cos inverse of x. And then cotangent of cosine of inverse cosine of x is cosine of cosine inverse of x times sine over sine of cosine inverse of x. So the sine of inverse cosine of x cancel, and now I'm left with cos of cos inverse of x, which is just x. Cos and cos inverse are inverses. They go away. I want the cosine of the angle whose cosine is x. That's just x. All right, number 12, I would like to solve this for all values of x. I have 2 cosine squared x plus cos x equals 0. I am set equal to the magical number 0, so I can factor this. I can factor out a cosine, and I'm left with 2 cosine of x times 2 cosine of x plus 1 equals 0. So this would simplify into, you can get two equations here. Cos x equals 0, or 2 cos x plus 1 equals 0. So if cosine of x is 0, I'm thinking on my unit circle, where is the co-height equal to 0? Well, the co-height is equal to 0 at 90 or 270. So x could be pi over 2, or x could be 3 pi over 2, and we'll do the general solution in a minute. Those are just the solutions between 0 and 360. 2 cosine of x plus 1 equals 0. If I subtract 1 from both sides, I'll get 2 cos x equals negative 1 divided by 2. Cos x is negative a half. And where is cosine negative? Well, cosine is negative in the second quadrant or the third quadrant. And where is cosine going to be negative a half? That means the adjacent is negative 1 and the hypotenuse is 2. Similarly here, negative 1, 2. Well, that's going to have a reference angle. That's going to make this other guy radical 3 or negative radical 3. And that's going to produce a reference angle of 60. In other words, my solution would be 120 or 180 plus 60, which is 240. In radians, 120 is 2 pi over 3. I'm going to let you guys convert that. And in radians, 240 is 4 pi over 3. Now, as we noticed, these solutions repeat themselves every 360 degrees, because if you take any of these solutions and add 360 or subtract 360 or any multiple of 360, then you end up in the same spot. So what I'm going to do is I'm going to add a repeater. And I'm going to add a repeater. 2 pi is 360 times any number integer I like. That's just called a repeater. And it allows you to generate what we call the general solution. And k is any integer. Some of you like to not write all that out. K is in the set of all integers. So you can write it out in symbols or in words. I don't really care. Some of you are symbol aficionados and you like the symbols. Some of you don't like symbols. Do it either way. I don't care. All right, 13, we have 3 cotangent squared of pi x equals 1. So first things first, I'd like to get that cotangent by itself. I'll divide by 3. So I have cotangent squared of pi x equals a third. I could take the square root. And so I get cotangent of pi x equals plus or minus 1 over rad 3. So I have cotangent of pi x is plus or minus 1 over rad 3. Let's just think about what that means. First of all, since cotangent can be positive or negative, I can be in any quadrant, which is actually sort of an advantage because I can just get the solution in quadrant 1 and be good with the other quadrants. So if I'm thinking cotangent of x is 1 over radical 3, or that would mean that the tangent is radical 3 over 1. So I'm looking at a radical 3 over 1 or 1 over radical 3, however you want to put it. Here's my angle. Well, that forces, I'm going to actually call this theta, excuse me. Get rid of this x. Let me redraw this. So we're going to have doot. The adjacent is 1. The opposite is radical 3. The angle is theta. The hypotenuse is 2. And I hope you recognize that theta has to be 60 degrees, which is pi over 3. So that's going to happen at a reference angle of 60 degrees in every quadrant. So I'm going to say theta is pi over 3, which is 60. Theta is also 2 pi over 3, which is 120. Theta could also be 4 pi over 3, which is 240, or 5 pi over 3, which is 300, plus my repeater. Now, I'm not solving for theta. That's just the input that can go into this function to get these outputs. I'm not solving for theta. I'm solving for x. But theta, or what's inside the trig function, is pi x. So how do I get pi by itself, x by itself rather? I can divide each of these guys by pi. So I'm dividing all my solutions by pi. In other words, the pi is already built into the equation, so x does not need the pi. And that's what's happening here. You're getting rid of the pi that you don't really need because it's already built into the equation. So here I'm getting all my general solutions. I have x. Pi over 3 divided by 3 pi is 1/3. Plus 2k, 2/3 plus 2k, 4/3 plus 2k, and 5/3 plus 2k, where k is any integer. Again, I don't care if you want to write that out in words or not. Okay, here we go. So 14, determine the amplitude, frequency, period, and range for this function. and name it at least 2 different ways. I don't want to put a billion of these on the assessment or the diagnostic because you've seen these recently, but just one to say, hey, make sure you know how to do it. All right, so here's my thing. My midline is here. So I'm looking above the midline, seeing how high the wave goes. Amplitude is 1. Frequency. That's the number of times that you're seeing the graph happen in 2 pi. So here's one cycle, boop. Here's another cycle, boop. Here's another cycle, boop. So I'm seeing 3 cycles in 2 pi. And my period is how long it takes to see one cycle, which happens, that red cycle happens in 2 pi over 3 on the x-axis. The range here would be from 1 to 3. So names. Well, if I take the red cycle that I just drew, all right, that red cycle is a negative sine cycle. Sine goes like this. Sine goes up, then down, then back up. It starts at the midline, ends at the midline. So negative sine would look like this. This is negative sine. This is positive sine. So if I'm looking at that first cycle, I have negative. I'm going to call this f of x. F of x is negative sine of, well, my frequency goes in the parentheses, 3x, and I shifted everything up 2 units. That's why our midline is at y equals 2. That is the horizontal shift. Okay, now I'm going to get a little more creative. I'm going to grab a cosine curve on here. That might be a little bit harder to see, but I can grab one very easily, and here it is. I'm going to start at the top and go down and come back up. So I'm starting here, going back, and coming back up. So that's the cosine curve I'm going to use. Now, as I've said before, this is a squeeze and a shift because regular cosine of x, okay, starts here, comes down to here, goes back up. So regular cosine looks like this. Okay, so I have to squeeze that first. So I'm going to squeeze that first into a chunk that has a domain like that, and then I'm shifting it back and moving it up. The moving it up part is easy. That's just the +2. But now the shifting, I squeeze first, then I shift. And people do these different ways. I think this is the easiest way to do it. We have to squeeze first, then shift. So squeezing, I'm dividing by 3 this time. And shifting, the shift we didn't discuss yet, I'm moving this over by, well, if this is negative pi over 3, this is all symmetric. I'm moving this over by pi over 6 to the left. So now I have to create a function that inverts that. So here's my function. I'm going to start by adding pi over 6 first. That's inverting the negative pi over 6. And then instead of dividing by 3, I'm going to take the whole thing and multiply by 3. And that is what goes in the parentheses. And by the way, there are lots of other rules. I'm just going to do 2 of them because we are on a video here. But there are lots of others, but those would 2 that would work. Okay, 15, consider triangle ABC. How many different triangles can be constructed if angle A is 40, A is 3, and B is 4? Well, so I have triangle ABC. A, B, C. A is 40, B is 4, and little a is 3. So the only way I can really do this is to use the law of sines to get another angle. So I have 40, 3, 4, and B. I'll call this x. So I have sine of 40 over 3 equals sine of x over 4. So I have 4 sine 40 equals 3 sine x. Divide by 3. So sine of x could be 4 sine 40 over 3. So from that, I can actually get angle x. I can do a second sine rather, of 4 sine 40 over 3. Whoops, sorry, I shouldn't have put the second parentheses in here. Okay, boop. I get 58.986. Now, that's not the only solution. X could be 58.986 or 180 minus that, because in the second quadrant, sine can be negative as well. So then I get or 121, 0130305, or whatever. Okay. So what I'm going to do is I'm going to make a little chart of this. So I know I have Perhaps I have two possibilities. I have 40 as the first angle in both. Then I said angle B could be 59 or so, or 121 or so. And then, well, that leaves me plenty of room for angle C in both cases. So I'm going to have two triangles. So now I want all angle measurements and all side measurements. So I'm going to have triangle 1 here. So triangle 1, we said A, B, C. We said B was 4, A was 3, angle A was 30, and we said angle B turned out to be like 58.986. And then you can go get, I'm just going to, well, never mind, I'll do them all. But so then from there, I can go back to my calculator and get the other angle. I can do 40, oops, 40 plus the 58.9, enter, subtract from 180, 180 minus the answer, and I'll get 81.013, so 81.013. So those are my angles. And my side, I can get that by the law of cosine. So I can say, I'll call this y. Okay, my angle opposite that is 81.3. So I can say that, let's see, 4 squared plus 3 squared minus 2 times 4 times 3 times cosine of 81.013, 03047 equals y squared. And I could take the square root of all of this to get y. So y is equal to the square root of all that. So I'm just going to do the square root of 4 squared plus 3 squared minus 2 times 4 times 3 cos of this angle. And if you're good with the calculator, you can do this pretty quickly. Hey, okay, enter. I get 4.6. And I didn't tell you where to round. I should have here. I'll just round this to the nearest tenth. 09, 4.6. So this guy is 4.6. All right, now triangle 2. Triangle 2. Triangle 2, instead what I have is, I have angle A as 40, but angle B, so this is still 3, this is still 4. Or did I have that backwards? Hold, please. I had that backwards. Okay, so this is 4, this is 3. Angle A is 40. Why did I write 30 here? That's 40. Okay, hold on a second. I'm just going to catch my breath here. So we have, I don't know, what was it, 121 point something. Let me go back up here to the list. 121.013. This was 121.0130305. And that left, we have to figure this out. 121 plus the 40, 180 minus that answer is going to give us the remaining angle. It's easy to get that angle. We have to get it anyway. 18.9869. 18.9869. And then I can use the law of cosine similarly. I have 4 to get y. 4 squared plus 3 squared minus 2 times 4 times 3. Cos of that 18.9869695 is y squared. So the square root of that will give us y. So we have square root of 4 squared plus 3 squared minus 2 times 4 times 3 times cos of this angle. Enter. I get 1.51, which if I round it off to the nearest tenth is 1.5. Woo! Okay, one more, and then we're good to go here. A straight line flight from Chicago to Los Angeles is, let me just zoom out here a bit. Okay, straight line flight from Chicago to Los Angeles is 1,742 miles. The straight line flight from New York to Los Angeles is 2,451 miles. The straight line flights from New York to Chicago and from New York to LA form an angle of 7 degrees. If a plane travels at an average speed of 400 miles per hour, how much time does it take to fly the straight line flight from New York to Chicago? Round to the nearest minute. So New York is on the East Coast here. Chicago is in the Midwest. Okay. I'll use its sports abbreviation, CHI. And LA is down here in sunny California. and rainless California. So we have a triangle that gets formed, okay? And I hope that you see that the angle between New York and, the Chicago flights is obtuse. That's important here. So Chicago to LA is 1,742 miles. New York to LA is 2,451 miles, and New York to Chicago, the angle from New York to Chicago and New York to LA forms an angle of 7 degrees. That's that angle. So what I have here is a case, as an ambiguous case. I have a side-side angle case here. So if I'm going to, by the way, you can actually use the law of cosines for this, but I'm going to use the law of sines in an intelligent way, because the law of sines is definitely faster. I'll call this angle x. So I end up with, let's see. So I have sine of x over 2451 equals sine of 7 over 1742. So I end up getting 2,451 sine of 7 equals 1742 sine of x. And I'll divide by 1742. And I get sine of x equals 2451 sine of 7 divided by 1742. And so I get 0.171 whatever here, 0.171 da 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 da. And so if I do inverse sine of that, 0.171, I will get an angle. And I will get 9 or 10 degrees. 9.87 degrees. Now, I hope you realize that's an absurd angle, because Chicago is opposite the largest route. So that can't be 9 degrees. That would leave, for the LA angle, that would leave like 160 degrees or so. So this is the wrong angle. So I had to subtract from 180 to get the right angle, because this is an ambiguous case situation, but I know a little bit more about the context of the case. So I know that angle has to be 170. So x has to be 170.126667 degrees. Okay, so now I have that angle. You might be wondering why we need that angle, but we do. So we have 170.126667. And that actually allows us to get the missing angle in the picture now. If I add 7 to that and subtract from 180, I'm doing that backwards, I get 2.873333 degrees. So 2.87733304 degrees. Because ultimately, I would like to get the distance from New York to Chicago, which I'm going to call y. So I'm going to get that now. So let me just label my steps, because I did this in sort of a kooky order. Here's step 1. This is my first set of steps. And now I'm doing step 2, part 2 of this, would be to get that y. So I'm going to use the law of cosines again. It's much easier. So y squared is equal to 2451 squared plus 1742 squared. 1742 squared minus 2 times 2451 times 1742 times the cosine of the 2.87 blah, blah, blah. Sorry, I'm squeezing this in here. And I would take the square root to get the distance from New York to Chicago. So I can do that. I can take the square root of 2451 squared plus 1742 squared minus 2 times 2451 times 1742 times cosine of, I just have to change this to a negative. So I'll just throw a negative in there. And I will get 716.53. Okay, that's my distance from New York to Chicago in miles. And I'm going 400 miles per hour. So this is in miles. This is miles from New York to Chicago. So now how am I going to convert that? So I have my distance is rate times time. Distance is 716.53 or so. The rate is 400 miles per hour times time. So I can divide this by 400. 716, divide that by 400. And I get 1.79 hours or so. What did I ask you to do this? I said round to the nearest minute. So 1.79, this is going to be 1 hour and so many minutes. So I could subtract 1, and I'm left with this fraction of an hour times 60, and I will get 47.47 minutes, which is, that's very close to the actual time it takes for that New York to Chicago flight if you've ever done it. They usually add a little bit of time getting out of LaGuardia or JFK or Newark because our airspace is so clogged. Anywho, hope you enjoyed that, and that's a wrap.